In section 6.1, we're going to look at a type of function called an exponential function. And exponential functions model quantities changing at constant percentages. Their equations are of the form f of x equals a times b to the x, where b is greater than 0 and b does not equal 1. The function's initial value is a, and b is the growth or decay factor. Okay, so for example, an exponential function could look like this. F of x equals 2 times 1.05 to the x. In this case, a is 2 and b is 1.05. Because b is greater than 1, this function is increasing, and it's increasing at a rate of 5%. Now, I know that because b is composed using 1 and r. So to get b, we would add 1 and r together. And so 1.05 is equal to 1 plus r. And if we solve this equation for r, we get r is equal to 0.05, which as a percentage is 5%. Okay, on the other hand, a function g of x, which is 5 times 0.97 to the x, here b is between 0 and 1, and so the function is decreasing. Okay, so b is equal to 1 minus r, so 0.97 is equal to 1 minus r, and solve this equation for r. Okay, so r is equal to 1 minus 0.97, which is 0.03, and that is a 3% decay rate. Okay, so let's take a look at some examples. A population is growing exponentially and can be modeled by the function p of t equals 1250 times 1.014 to the t, where t is in years. Determine the initial population. Okay, so the initial population occurs when t is equal to 0. And we can find p of 0, which is 1250 times 1.014 to the 0 power, but 1.014 to the 0 is just 1, and so we're left with 1250, which is in fact the value of a. Determine the rate of growth. Okay, so we're going to look at b this time. And since b is equal to 1.014, to find r, we're just going to subtract 1 from this number. Okay, so r is equal to b minus 1, or 1.014 minus 1, which is 0.014. Okay, as a percentage, that's 1.4%. And I would get that by just multiplying this value, 0.014, by 100. Find the population after 10 years. Okay, so we're going to evaluate p of 10. Okay, so that's 1250 times 1.014 to the 10th power, or approximately 1,436. Okay, example 2, a car's value was initially $22,000 and was depreciating by 15% each year. So we want to determine a formula modeling the car's value over time. So we'll call this V of t. Okay, so it was initially $22,000, that's A, and depreciating by 15% each year. So since it's depreciating, we're going to use the formula b is equal to 1 minus r, or 1 minus 0.15. Okay, but we can simplify that, and we would get 0.85 to the t. Okay, and then in part B, if the car continues to depreciate by the same percentage, what will the car be worth after 10 years? Okay, so we're going to find V of 10. And so that's 22,000 times 0.85 to the 10th power, or approximately $4,331.